Okay, just some extra calculus problems. Ben Nicolay suggested these, and anybody else who wants to watch um, is welcome to. Okay, so the first one, I hope everybody's getting along and adjusting to the coronavirus. Um, the first problem we'll take a look at is Big Quiz 7 problem. We wanted to maximize or find the extreme values of this function on the closed interval. I think that's the question. Let me walk over to my big screen and look. 8e to the x minus e to the 2x. 8e to the x, yeah. Okay. So the derivative of this character, you're going to need that. So f prime of x is just 8e to the x minus e to the 2x, and then you need the chain rule, so times 2. Okay, and then we have to set this equal to 0, so I have 8e to the x minus 2e to the 2x. And then I want to factor, so 0 equals, I can factor out 2. I end up with, and factor out an e to the x as well. Okay, so I end up with 4 and then minus e to the 1x. Right, so if you redistributed, you would have 8e to the x minus 2 e to the x times e to the x. And if you have a repeated base like that, you have to add the exponents, right? So if you have a to the x times a to the y, it's a to the x plus y. So if you have e to the x times e to the x, it's e to the x plus x, which is e to the 2x, which gets you back to there. Okay, then you set the parts equal to 0. So 2e to the x equals 0. This doesn't have any solutions, right? E to the x is always positive. That's an exponential growth thing, right, that we're hearing on the news all this week. Exponential growth. This thing will never be 0. Anyways, take the other guy and set it equal to 0. And this is an exponential equation, so you need to use natural logs to solve it. Take the ln of both sides. So ln of e to the x, ln of 4, and we have x equals ln of 4. Okay, assuming I didn't make any silly mistakes. So that's one critical number, and we need to kind of evaluate this function at the critical numbers and at the endpoints. So -1, f of 2, and then f of ln 4. Okay. Okay, so plug in -1 into here. That'll be 8e to the -1 minus e to the -2. Plug in 2, I get 8e to the, 2 minus e to the 4th. Plug in ln 4, maybe this is a little harder, but it's 8e to the ln of 4 minus e to the 2 ln 4. And then we could simplify both of these terms because they are inverse rules are going to apply. So e to the ln of 4, the e and the ln will cancel each other out, and you just have 4. Right? And then for this guy, first you do a power rule. So you'll have e to the ln of 4 squared. And then you could do the inverse rule to remove the e and the ln, right? So you get 32 minus 4 squared, which is 16. And that should equal 16. I think, assuming I didn't make any mistakes, that seems like that should be ln2, though. I'm freaking wondering. No, it's 8, I think, or 16, sorry. I think it's 16, unless I made some mistake in here. I can't see it, and I know I did when I first wrote the quiz, so it's driving me nuts. All right, I think it's fine, though. If nothing else, that's the idea. Okay, then you put these into your calculator and evaluate them and see what they are, because it's not entirely clear what the heck these things are, right? So I'm going to go over and get my calculator. Find it. 8 times e to the -1 minus e to the -2 is I'm gonna have to get out of this mode. Is about 2.8. Then this guy, 8e squared minus e to the fourth is about 4.5. Okay, so this guy here should be your minimum. Okay, and then this guy here, the ln4 one, should be your maximum. Okay, so barring any silly mistakes, that's your answer for that. Okay, let's look at the 4.1, some 4.1 problems. We have 23. Okay, and I didn't bring my book home. It's still sitting in my office, so I'm kind of toggling in between screens here. 23, it looks like we're finding critical numbers. F of x equals x squared log base 2 of x squared plus 1. Okay. Okay. So what's going on here? I need to get the derivative and set it equal to 0. So f prime of x. And if you want to, you can always turn this into an ln, ln of x squared plus 1 over ln2, if that makes life easier, or maybe not, right? So ln of x squared plus 1 all over ln2. So that was like a change of base formula that you probably saw in pre-calc. Okay. All right, once you've done that, then you could do your, sorry, this isn't the derivative yet. Once you do that, then you do your derivative, which you're going to need a product rule for. Right? So you can leave this alone if you want. So x squared times the derivative of this thing. There's this constant, 1 over ln2. And then the derivative of ln of x squared plus 1. So that's 1 all over x squared plus 1 times the derivative of x squared plus 1 by the chain rule. That's 2x. So x squared, the derivative of that is 2x, and the derivative of 1 is 0. Okay. And then plus, now you take the derivative of x squared. So that would just be 2x times the 1 over ln2, if you wish, times the ln of x squared plus 1. Okay. Now we got to zip in there and do some nice simplification. We want to set it equal to 0 as well. You can factor material out if you want to. Maybe that'll help. I don't know. Let's try that. So I can factor out 1 all over ln2, right? And the numerator. So I got rid of this and this. In the numerator, I can pull out a 2x from each term. Okay, so I'll have a 2x, and then what's left over, right? So I'll have an x squared all over x squared plus 1, and then plus ln of x squared plus 1. Okay, for the critical numbers now, you're setting each part equal to 0. So you can set this equal to 0. So 2x all over ln of 2 equals 0. So 2x must equal 0. And then x will just equal 0. So one critical number there. Other critical numbers, setting this equal to 0. Okay? There's no issues with the denominator or with the domain here. So all real numbers will work inside the log because this thing's squared. So make it a positive. And you'll never have anything equal to 0 or less than 0. So you're good with domain issues. The only critical numbers will be where this is equal to 0. Okay, so I'll take x squared all over x squared plus 1 plus ln of x squared plus 1 and set that thing equal to 0. Okay, it's you can multiply through by x squared plus 1 if you wish. You get x squared plus 1 ln of x squared plus 1 equals 0. You can move this x squared to the other side. So you'll get x squared plus 1 times ln of x squared plus 1 equals negative x squared. you could divide both sides by this expression, and you'll get ln of x squared plus 1 equals negative x squared all over x squared plus 1. And then you could say e to this power equals this stuff. So you could say e to the negative x squared all over x squared plus 1 equals x squared plus 1. Not really sure what else to do, you know. Seems like I'm not getting any solutions. What the heck is x squared plus 1? That's going to be a parabola shifted up one place. This is some weird kind of exponential. I have no idea what it's doing. Sometimes I want you to do like L'Hopital's, or not L'Hopital's, but Newton's method, and find the intersects that way. That's just ridiculous here, though. The only thing I think of doing is going back and kind of checking your work if you get stuck or something like that. But I think it's probably something stupid. Not stupid, but it's probably that there's no way to get a negative out of this natural log. And yeah, that's going to be the key there. This thing right here is always going to be, sorry, this thing right here is always going to be greater than 0. So you can't get a negative thing out of it. The numerator is going to be positive because of the x squared. The denominator is going to be positive because of the x squared plus 1. And then if you put a negative in there, this is going to be negative. The ln of x squared plus 1, though, so if you have x squared plus 1, you know that's greater than or equal to 1. And then you can take the ln of both sides because of the kind of function this is. Greater than or equal to the ln of 1, and that's greater than or equal to 0. Okay, so there's no, the only place that would work is if x was actually equal to 0. Otherwise, it's going to be greater than 0, and we already have x equaling 0 as one of our critical numbers. So yeah, there's no way for this guy to work right there, and I would say the only critical number then is x equals 0. Okay. Okay, so that's 4.123. Let's look at 37. And let me toggle over to my book and try to find the problem. Okay, so what are we doing? Find the absolute extrema on the closed interval. 37. Oh my gosh, it's one of those weird floor or ceiling functions, and I never know which it is. I think it's a floor function. I'll pretend it's a floor function, okay? On the interval from -2 to 2. The max and the min of this thing is just going to be at the endpoints because of what this thing looks like, right? So the floor, if it's the floor function they're talking about, it'll be the floor of -2 is equal to +2. Sorry, is equal to -2.0, right? The floor of -2.01 is equal to, so if you think about the number line, here's -2. -2.01 is where? It's over here, so that would go down to -3. You got to be a little careful, right? So negative, or let's try like 1.5. 1.5, the floor of that is equal to 1. Right? So the graph of this thing, assuming it's the floor and not the ceiling, you have -1, -2, 1, 2. I'm not going to be going after critical points, is sort of the point. It'll just be, this thing is kind of an increasing function, kind of, constant plus increasing. Okay, so at -2, anything like -2.1 is going to be down here, but that's out of that. So I'm looking at numbers like -1.9. These guys are going to shoot down to -2. okay, all the way up to -1. And then anything up to -1 and including -1 is going to get knocked down to -1 like that. And then anything from 0 to 0.5 is going to become 0. So it's going to end up looking like this. And then on 2, it's going to get knocked down like that, right? All the way up to the floor of 2, which will just be 2. Okay. Okay. The ceiling version of that is basically this will go here, this will go here, this will go here, this will go here, and then at it'll end right here with 2. Okay. So I don't want to draw that. Hopefully this is the floor function. Let me cheat a little bit and see what they say. So yeah, it's going to be it has to be the floor. Okay, so right, the minimum is going to be right here. So min for x values that give you -2, right? So there's a minimum of x, minimum of y equals -2. For x values that are in this interval. So for x greater than or equal to -2, but then less than -1, because the floor of -1 is going to be -1. Okay? And then the maximum is going to be this point. And there's only one point that will give you that maximum, and that's 2. So the max is y equals 2 when x is equal to 2. Okay? Okay, so 90% sure that's the floor. But computer science is where that will be. Okay, so number 45. Let me toggle over to my book and take a look. 45. There's another one of those. Yeah, okay, so another extrema on a closed interval. 45. E to the x sine x, y equals e to the x sine x on the interval from 0 to pi. Okay, need the derivative, so y prime is e to the x, take derivative of sine, plus the derivative of e to the x is just e to the x times, leave sine x alone. Then we want to set this equal to 0, so you have e to the x times cosine of x plus sine x. And we have to figure out where cosine x is equal to sine x then, right? So we want to know where cosine x plus sine x is equal to 0. In other words, where is cosine x equal to negative sine x? Sorry, I went off the page. Where is cosine x equal to negative sine x? Okay. And to figure that out, you could divide both sides by cosine and then multiply both sides by -1. So you get sine x all over cosine x equals -1, which is tan, right? So I want to know where is tan of x equal to -1 in that interval from 0 to pi. Okay. You can think about the unit circle. So tan of pi over 4 is +1. Then tan will be negative in this quadrant. So we need 1, 2, 3 pi over 4. So x equals 3 pi over 4. There's another answer over here. Tan is negative over here as well, but it's not in our interval. So the only real critical number is 3 pi over 4. And so we go again and check, what is y of 0? What is y of 3 pi over 4? And then what is y of pi? Okay, so y of 0. Sine of 0 is just 0. So you'll have e to the 0, which is 1, times 0, which is 0. Then you have e to the 3 pi over 4 times sine of 3 pi over 4. Sine of 3 pi over 4 for the unit circle. 1, 2, 3 pi over 4 sine is positive, so that's root 2 over 2. I'll need my calculator for that guy. And then pi, so sine of pi is 0. So there's going to be mins at x equals 0 and x equals pi, basically, of y equals 0. And then this guy's going to be our max. And I'm not even going to evaluate what that number is. So a max at 3 pi over 4 of e to the 3 pi over 4 times root 2 over 2. Okay, it's a positive number, so it's it's not 0, it's not negative, so it must be greater than 0, so it has to be the max. Okay, wait, one more. This is 4.2, number 55. Keep going off the video, I'm sorry. Okay, so let me scroll over and hopefully 4.2. I'm looking for it in the book. Again, I have to kind of toggle around. 4.2, going to my exercises, 55. It's another one of those log things, huh? So 4.2, crud, it just jumped out of it. Slowly scrolling. Found it. A mean value theorem. Okay. Number 55. Y equals x log 2 of x on the interval from 1 to 2. Okay, so I need the derivative. Again, when you deal with these logs with weird bases, just use your conversion formula, your base conversion formula, turn it into ln x over ln2. And then that ln2 part is just going to be a constant. Literally, you could pull it out like 1 over ln2 times x ln x, right? So you think of it as a constant out in front. And to take the derivative, y prime, you kind of can just leave the 1 over ln2 alone. And the derivative of x is 1 times ln x, plus leave x alone times the derivative of ln of x is 1 over x. Right? So you're going to end up with, and we have to set it equal to 0. So you get 1 over ln2 times, oh, I don't know why I'm setting it equal to 0. This is a mean value theorem problem, sorry. We need the derivative anyway, so all right, here's the derivative. So it's ln x plus 1. All right. I need to make sure that the thing is continuous on the closed interval, and surely it is. The log only has issues at 0 and all numbers below 0, and that's not in this interval. X is continuous everywhere. The product of two continuous things is also continuous, so it's continuous on this closed interval. Is it differentiable on this interval, and on the open interval in particular? And yes, it is. The only issues, again, would be at 0 or numbers less than 0, and none of that is in this interval. Okay? So yes, it's differentiable. Yes, it's continuous, so we can apply the mean value theorem. So I have to take this 1 all over ln2 times ln of x plus 1 and set it equal to the f of a. So you're looking at f of 2. So you plug 2 into this expression or this expression. I'll use this one. Okay, so if you plug 2 in there, you get 2 times ln of 2 over ln of 2. Okay, that's just going to be 1. And then minus, plug 1 in there, so 1 times ln of 0, or ln of 1 is just 0. So you'd have ln of 1 times ln of 1 over ln of 2. ln of 1 is 0. So anything times 0 is just going to be 0. And this will be all over 2 minus 1. Right? So I have 1 all over ln 2 times ln of x plus 1. That'll equal 2 all over 1, or just 2. And then multiply both sides by ln 2. So you get ln x plus 1 equals 2 ln 2. Right? And then you can move the 1 over. So you get ln x equals, you could pull this inside using the power rule, and that'd be ln of 2 squared, or ln 4. Move the 1 over, and you get minus 1. Then you need to exponentiate both sides. So you'd end up with x equaling e to the ln 4 minus 1. Okay? Remember your rules for exponents. You can split this up. If you have e to the x plus y, that's the same as e to the x times e to the y. You're just not used to going in that reverse direction. So this is really e to the ln 4 times e to the negative 1, which is equal to e to the ln 4. Those are inverses, so that's just 4 times e to the negative 1. Right? And that should be in this interval. Okay, so this e is approximately like 3, so 4 over 3 will be in there. And that will be that particular number c, such that, you know, f prime of c is equal to f of b minus f of a over b minus a. Okay, I hope you have a good one, and see you next time.